Greetings everyone. Today we're going to explore solving real-life applications using exponentials. So we're going to have to use logarithms, natural logs, base E, exponents. There's going to be converting, solving for a variable. So everything we've learned up to this point, we're going to apply to real-life scenarios. Some previous knowledge needed. So you already understand what an exponential equation is. We've talked about this when writing exponentials. And what that includes is the value out front is our initial amount. So when we were given a set of points or a table, this was our zero amount on our table, or it was considered our y-intercept. The b value, that was considered our factor. It's the amount we're multiplying by each time. So it's the change that we're seeing each time. So these values still matter and are still going to be included. X is our x-axis value, and then f of x, often referred to as y, is going to be our answer, our total. So what I'd like you to try is with this question, please pause the video, try it out. Think about what values are important. Where can I plug in a value? What value can I solve for? So again, please take a moment to pause. So let's take a look. My first suggestion is to underline each piece of information that you feel is important. I have a starting value of $150,000 in 2002. I am given the equation and I want to know when would it be worth $20,000. So as I take a look, the $150,000 amount is already in the formula, so that's taken care of. Let's look at what variables I have. I don't know my A, I don't know T. E is a number, that is not a variable, that is our number. So the other number that I have is $20,000, but let's also identify our question. Find when. Find when implies I'm trying to find time, a year, a date. So I don't know my time value. So T is going to stay, 0.0645 is going to stay, E is going to stay, 150,000 is going to stay. Therefore, A, meaning my total amount, my final amount, is 200,000. So this now looks like every equation we've worked on up to this point. My goal is to isolate that base and to solve for T. So first I need to divide both sides by 150,000. Kick that to the other side. Don't plug that in your calculator when you have so many zeros. Just drop all those zeros. So that takes me down to 4/3 equals base E, 0.0645 T. I've isolated the base E. I need to solve for the exponent. I can't solve the way it is, which means I have to convert. E becomes ln. The exponent becomes the answer. What's remaining becomes my main value. So now it's much more obvious on how to solve for T. So in my calculator, I would type in ln of 4/3, close the parenthesis, then divide by 0.0645 to get T by itself. Notice we're trying to find when. So I can answer as a year, I can answer for an amount of months or amount of years. You have a few options. So please try in your calculator to find that value and determine how you would answer that. Let's try to be a little more specific though. Okay, I've provided for you the notes that you can have glued into your notebook so you don't have to write all of these problems down. If you were absent, you might want to print off these notes that were provided to you in Google Classroom. Let's take a more specific look at exponential growth or decay. Now you've already, again, written these equations. We've always had an initial amount. That stays the same. You're always going to have something that you're starting with. So you're going to have a number out front. That is your initial amount. Before we called this value a factor, we're just going to be a little more specific and call it a rate. A rate of change is the same as what are you multiplying by every time. Now, often you're given it as a percent, so make sure you write that as a decimal. So don't forget that 5.25% would be written as 0.0525 as a decimal. T is still time. Before this was an X, now it's time. So that time could be years, months, days, most commonly years though. And of course, you're always going to have a final value, your answer. What's the total in the end of whatever scenario we're talking about? It is assumed that the basics of exponential growth and decay equations you will know. You know and have memorized that there's an initial amount, there's a rate of change, there's a time exponent, there's a final answer. Now, a little more specifically, are these two formulas for exponential growth and decay that you're going to most use. The reason why is because when I'm talking about a rate of, something grows 5% each year. Well, 5% of what? 5% of 100, starting with 100% of what I had to begin with. So 100% as a decimal is equal to 1.00. So I have 100% and I'm adding on the rate. So a lot of times you end up with like 1.25 would be 125%. So you're keeping the original 100% and adding on. Or the opposite, where you have subtracting. So if I have exponential decay or depreciation or taking something away, you're going to have 100% subtract the value or percent that it's changing by. So these two, again, there is an expectation. These two would be the two that I 100% would work on memorizing. This is also from Algebra 1, so you might have it in some previous notes. So let's take a look at how we might use these equations. I have a new boat. It was purchased July 2011 for $50,000. It's depreciating by 12% each year. Let's stop there and underline the values that we might use that would be helpful. I bought it for $50,000. 2011 is when I bought it. It's depreciating 12%. Now let's identify what do each of those underlined values represent, or what variable might they be? Well, if I bought it for $50,000, that's my initial amount. That's my starting value. 12%, that's definitely a rate. Anytime you see a percent, that's your rate of change. Depreciates implies it's going to be a negative. And I have a starting year. I don't know how I'm going to quite use that yet. So the first question is I want to find the value of the boat to the nearest $100 in July of 2020. So now I feel like I've got two values of time here. If I started in 2011 and I'm going till 2020, my time is actually 9 years. So don't put in the years. I mean, we're not measuring from, year 0. We're measuring 9 years of ownership. So in my formula, I've got my initial amount. I start with 100% of that, and I'm decreasing by 12% each year. And I want to know, how much is it worth after 9 years? So be careful when you plug that in. Make sure you use parentheses accordingly or order of operations correctly. And make sure your answer makes sense. If I end up with a y value, notice I need to write it to the nearest $100. That matters. I end up with $15,800. Labels matter. Think about, does that make sense? If I was to put this in a table, in 2011, it was worth 50,000. It depreciates, and in 2020, they're saying it's worth 15,000. That makes sense for depreciation. Boats, cars, they all depreciate so drastically. So this makes sense. What numbers don't make sense? Well, let's see. If the price went up, that doesn't make sense. If I had a negative, that doesn't make sense. So I'm going to stress this. Makes sense. Don't leave an answer that doesn't make sense. All right, our second question says, during what year will the boat be worth $20,000? So my question is, what year? I don't know the year. My time is unknown, but I know my final amount is $20,000. So same formula to start with. My initial value stays the same. I'm still depreciating by 12%. But this time I don't know my time, but I do know where I end up. Now let's make a little guess. Look back at the light blue that I have here. If I'm looking for when it's 20,000, that's going to be somewhere in the middle. So I should end up with an answer that's greater than 0 but less than 9 years. So let's see what happens. First of all, isolate the base. So divide both sides by 50,000. Don't use your calculator with this many zeros. Cross them all off if you got 2/5. Let's take care of the 1 minus 0.12. That's a simple calculation, 0.88t. I have an exponential that I don't know how to solve. Exponentials convert to what? To logs. Exponentials convert to logs. I hope you said that out loud. So log, the base becomes the base, the exponent becomes the answer, what's remaining becomes your main value. This I can type into my calculator. So if you use change of base, make sure you use parentheses. If you use the log function under math, make sure you're careful with that as well. So I ended up with t is approximately 7.16785. I'm going to write down a bunch of decimals, then decide. So it says, during what year will it be worth? Well, it says in 7 years. So if I bought it in 2011, that would mean in 2018, it's worth $20,000. Now, was my guess right? I said it needed to be greater than 0 but less than 9, and I got 7. So that's right on track with making sense with the other problems. So makes sense, okay? I'm going to keep stressing that. Let's take a look at some investment formulas. Again, your note sheets will be helpful here. Notice the change. Instead of initial amount, we have the letter P. Well, that just stands for principal amount. It means the same thing. It's my starting point, my starting money this time. I still have R, a rate that I'm going to gain money. Now I don't have to worry about minus because this is an investment. I'm earning money on my investment. Now if we're talking stocks, that's a whole nother world. But here I'm talking about a bank account. So they better not take my money. We still have time. So how long is it going to sit there and gain money for? And then I'll arrive at my final answer. Now, if I'm talking about compounded, underline or box that, compounded. What that means is, if I'm earning interest quarterly, then I need to take that rate by 4. And then my time, let's say if it's quarterly for 6 years, I'm actually going to earn interest 24 times. So n needs to also be multiplied by the t value. Okay, so quarterly would be 4, yearly would be 12, biannually 2, monthly 12. All those are going to be keywords, so look for those. So compounded matters, and this keyword of n, how often is it compounded? We also have compounded continuously. So my keyword here is continuously, meaning forever, constantly. It's hard to imagine that, but every second I'm earning interest. So that we can actually use base E for. So we don't have to worry about N because it's nonstop. So I have my principal amount times E to the RT. Let's look at some examples. First example, I'm investing $3,000 into a bank that pays 4% interest compounded monthly. Underline what's important. Take a moment to think about that. I'm investing $3,000, 4% interest compounded monthly. So let's label, what do we have here? $3,000 is my starting point, it's my starting amount. 4% would be my rate. Compounded determines my formula, and monthly would be represented by a 12, and that would be my N value. So the first question asks, how much money will you have after 6 years? So that's my time. It's sitting in there for 6 years. So for my formula, I don't know how much money. That is my question. So I have an unknown value. I'm starting with $3,000. I have 100% of that, and I'm adding on 4% every month. So monthly, we have to think of that percentage spread out over months. And after 6 years, I have to times that by 12. So I'm actually going to earn interest 72 times because 12 times 6. Now be very careful when you plug that into your calculator. If it's helpful, maybe take care of simplifying a few things first. I'm going to take care of that entire inside of the parentheses. When I do that, I'm going to leave it in fraction form. If you know how to use your fraction key, it actually ends up being 301 over 300, okay? Or the decimal value, 0.003 repeating, okay? But I want to be exact, so I'm going to use the fraction that I get there. So if I plug that in, let's make a guess. It has to be more than 3,000. I got to make some money here. This is a positive gain. So more than 3,000, but if I was to guess, maybe less than 10,000? I mean, I don't think I'm going to make that much money in 6 years. So I'm just going to say less than 10,000 would make sense. So plug that in. Be careful with your parentheses, please. Let's see what we end up with here. I'm also going to type it in. I ended up with an answer. It doesn't tell me how to round, so I'm going to stick to the usual money rounding of 2 decimal places. Now, does this make sense? I started with 3,000. I gained 800 bucks. 4% is low out of 100%, right? But also it's actually pretty good compared to the real world for a basic savings account. So earning 800 bucks is pretty good for a basic account. So it makes sense. I gained money. Let's take a look at another scenario. To the nearest tenth of a year, that's telling me how to round. It's also telling me I don't know my t value, so that's what I'm trying to find. How much money, or excuse me, how long must you leave the money in the bank for it to reach 5,000? So that's my final value. So I'm going to plug in 5,000. That's my goal. I'm starting with 3,000. I still have a rate of 4%. I'm still compounding monthly. But I don't know for how many years. That's my unknown. So as always, let's divide both sides by that initial amount because it's in the way. I need to isolate that base. Let's cut off those zeros. So we end up with 5/3 equals. Now I already simplified this parentheses earlier, so I'm going to do the same thing. And it's 12t. Now I can't solve that easily, so I'm going to convert log. The base becomes the base. The exponent becomes the answer. What's remaining becomes my main value. So plug that into your calculator and be very careful with your parentheses if you're using change of base. If you're using the updated graphing calculators, it'd be very helpful to use that log option. It's a little less to type in as far as parentheses go. So I'm also typing that in, but once I type all of this in, what do I have to do here? That's not my answer. I still have to take all that and divide by 12. So I ended up with an answer when I did that of t is approximately 12.7919. I'm going to write a bunch down first. So it says to the nearest 10th of a year. So my final answer is actually going to be 12.8 years if I was to label it, because every answer needs a label. Think about that. Does that make sense? If I look back up here, let's look back at our original situation. In 6 years, I got to 3,800. Now I'm saying in 12 years, I got to 5,000. Doubled the years, over doubled my money. Well, that makes sense because the more time you leave your money in, the more money you make because you're earning interest on top of interest on top of interest. So that's why they say to invest when you're younger. Let money sit in an account and just rake up the interest. So it makes sense. It's not negative. I didn't go down. I went up. 12 years makes sense. Let's take a look at another example. Take a moment to pause, read through the scenario, and identify key information. So to start off, I'm going to underline the 4,000, the rate, and the keywords compounded continuously. Let's identify what those would represent as variables. I'm investing $4,000. Excuse me, Maya is. I like to dream that I have money. So Maya is investing $4,000. That's my initial amount or my principal amount. I have a rate. It even tells me rate. That makes it nice and easy. Rate of 5.75. Compounded tells me my formula, specifically continuously. So that means base E. So that might be helpful to jot that down. Now determine to the nearest dollar. It's telling me how to round the amount of money she will have after 7 years. So there's my time, meaning I don't know how much money. I don't know my amount. This variable doesn't matter. It can be Y, A. You could write out money. I mean, it doesn't matter. It's your ending amount. I'm starting off with a principal amount of $4,000, base E to the 0.0575 times 7. So my rate times my time. So this is really just a drill and kill type problem, meaning you're just going to plug it into the calculator and see what spits out. So in this case, I ended up with approximately 59, 82, 23, 57. I'm writing it all down because I'm not answering yet. It says to the nearest dollar. So my amount is going to be $5,982 to the nearest dollar. Makes sense. I went up from 4,000 to almost 6,000. Part B, determine how many years to the nearest 10th of a year. That tells me how to round. It will take her initial investment to reach $6,000. So now, how many years is my question? That's my unknown T, but I'm given my final amount. So when I plug into my formula, I know my end game is 6,000. My starting game was 4,000. I still have the same rate of 0.0575, but I don't know my T value. Now, let's make a guess here, okay? Look up above here. If 7 years led me to a value of 59.82, then how am I going to get to 6,000? 7 and a little bit. It's so close, so I should be pretty darn close to 7. So let's divide that 4,000 over. cut off those zeros, don't plug that in your calculator, reduce 3/2 equals e to the 0.0575 t. Can I solve that? Not the way it is, which means I need some help. I need to convert to make this make sense. So e becomes ln, natural log. The exponent becomes the answer. And what's remaining becomes your main value. So let's plug in ln, use parentheses for 3 divided by 2, 3/2, or 1.5. That's not my answer though. I still have to divide by 0.0575. Okay, so take this, all of that, and divide by 0.0575. I'm rounding to the nearest tenth of a year, so my time is approximately 7.1 years. Now that makes sense, right? I said 7 and a little bit, so 7.1 makes sense. Okay, keep checking that. It's one thing on an assessment or just in life to make a little calculation error, but it's another thing to be okay with something that doesn't even make sense. Okay, that means we're not reflecting on the problem or what's going on. Let's quickly talk about half-life. We're not going to use this one quite as much, but half-life takes care of the inside of the parentheses. Half-life implies it's 50%, so why not make the formula smaller? The t is still time. The h, though, that's going to be a little bit new. Here we're talking about the time it takes for the original amount to be halved. Okay, so t over h is a little bit new. So first, let's underline our key information. If you need to pause to think this through, please do so. But it has a half-life of 15 hours. How long to the nearest tenth of an hour? That's how I'm going to round. Will it take 120 grams to decay to 25 grams? So here I know my starting amount. So this is what I'm starting with. This is what I'm ending with. Okay. 15 hours is the half-life, and I'm trying to find how long, so I'm trying to find t. If I plug it into the formula, I'm ending with 25, I'm starting with 120, I have 0.5 in parentheses, and I have t over 15, because 15 is how long it takes to execute a half-life. So, as always, let's divide that initial amount over. So 25 divided by 120, you could leave that maybe as a fraction. That might be a little bit easier to type in. So if you know how to use that on your calculator, or you could just leave it the way it is. I can see quickly that these are both divisible by 5. So maybe you want to take care of that. Okay. So next, I want to see if I can solve for t yet. But t's in my exponent, and I can't solve this the way it is, so it's time to convert. Please do so. The base becomes the base, the exponent becomes the answer, what's remaining becomes your main value. Okay, so if you're going to type that again in your calculator, I can't stress this enough. If you're using a scientific calculator, that change of base needs some parentheses carefully placed. Once I find this value, though, I need to times it by 15 to isolate that t value, to find my time. So I plug it in my calculator, press equals, and then click times 15. That's just out of habit for me. But we end up with approximately 33.9455. I'm just going to write a bunch down, then decide. It says round to the nearest tenth of an hour. So tenth of an hour would mean 33.9 hours is what I'm looking for. Okay, let's see if this makes sense. So it decreases by half every 15 hours. Okay, well, if I have 33 hours, that means it's halved once, halved twice, and then a little bit. Okay, well, let's see. 120 cut in half is 60. 60 cut in half is 30. And I'm trying to get to 25. So it's like I halved it just a little bit more, and that makes sense because I'm just over 30. So 33.9 hours makes sense. So I'm okay with that. If I half and half, that would make sense. Okay, if you have questions, you really need to seek out help in the Sabre Center with whichever teacher can help you out. See me before or after school, but this is a tougher section just because not a lot of students have that persistence and that ability to break down the information, and we need to work on that. That stamina to problem solve is so important. So please ask for help. Work on this section. Your assignment will be posted in Google Classroom. Make sure you recognize what that is. We're going to continue working on this in class. So until next time, have a good one.